Okay, in our today's class, we are going to see types of functions. The first type of function that we are going to see right here is the signum function. The signum function is in fact defined as f of x equals absolute value of x over x. This is the general definition, and it can be represented as f of x equals to signum x sgn x. And the signum function is one example of piecewise defined function. It's a piecewise defined function that has three components that are defined for various domains. Now, so the first component is 1, 0, and negative 1. That's three components, and it will be 1 for every x greater than 0, and it will be 0 for every x equals to 0, and it will be negative 1 for every x less than 0. Now, coming to the graphical representation of the signum function. Now, from these components, you can clearly understand that the range is 1 for every positive domain, means it's a line parallel to the x-axis, just like this at negative 1. And 0, 0 is a dot at the origin. This is another component of the graph. And the other one is y is equals to negative 1 for every negative domain. So this is the graph of the signum function. Now let us see the general properties of the signum function, starting from the domain of the function. The domain is the set of all real numbers, and the range are negative 1, 0, and 1. So there are basically three ranges. Let's say unifunction, in fact. It has only three ranges, negative 1, 1, and 0. Now the other thing is dealing with the continuity of the function. Now to prove the continuity, whether the function is continuous or not. So one tool of confirming a function is continuous is the limit of the function. Now when you see the limit of the function as x approaches to 0 in general, we can clearly see that the limit of signum x as x approaches to 0 doesn't exist, because the right and the left side limits are not equal. Now this confirms that this function is discontinuous as at x is equals to 0. I said discontinuous function at x equals 0 means, in other words, it's continuous for the set of all real numbers with the exception of x equals 0. Now this is another exercise for you to practice. Now try this one, and you can write the solution if it is possible at the comment section. Thank you very much. I'll see you in another video.